This is the NVLink spine. This is 100% copper. Copper coax. It directly connects all of the NVLink chips to all of the GPUs, directly connected over this entire spine, so that every single 144 Blackwell dies, or in 72 different packages, are talking to each other at the same time without blocking, all across this NVLink spine. The bandwidth of this is about 130 terabytes per second. 132, I know. No, wait for it. 130 terabytes per second. If it's in bits, 130 terabytes per second. It is more than the data rate of the peak traffic of the world's entire internet traffic on this backplane. And yeah. So this is how you shrink the internet into 60 pounds. NVLink. We know that AI is incredibly important technology. We know for a fact now that AI is software that could revolutionize, transform every industry. It can do these amazing things. That we know. We also know that the way you process AI is fundamentally different than the way we used to process software written by hand. Machine learning software is developed differently and it runs differently. The architecture of the systems, the architecture of the software, completely different. The way the networking works, completely different. The way it accesses storage, completely different. So we know that the technology can do different things, incredible things. It's intelligent. We also know that it's developed in a fundamentally different way and needs new computers. The thing that's really interesting is, what does this all mean to countries, to companies, to society? And this is an observation that we made almost a decade ago that now everyone is awakening to. That in fact, these AI data centers are not data centers at all. They're not data centers in the classical sense of a data center, storing your files that you retrieve. These data centers are not storing our files. It has one job and one job only: to produce intelligent tokens, the generation of AI. These factories of AI look like data centers in the sense that they have a lot of computers inside, but that's where everything breaks down. How it's designed, the scale at which it's manufactured or scaled, designed, and built, and how it's used, and how it's orchestrated and provisioned, operated, how you think about it. For example, nobody really thinks about their data center as a revenue-generating facility. I said something that everybody goes, yeah, I think you're right. Nobody ever thinks about a data center as a revenue-generating facility, but they think of their factories, their car factories, as revenue-generating facilities. And they can't wait to build another factory, because whenever you build a factory, revenue grows shortly after. You could build more things for more people. Those ideas are exactly the same ideas in these AI factories. They are revenue-generating facilities, and they are designed to manufacture tokens. And these tokens can be reformulated into productive intelligence for so many industries that AI factories are now part of a country's infrastructure, which is the reason why you see me running around the world talking to heads of states, because they all want to have AI factories. They all want AI to be part of their infrastructure. They want AI to be a growth manufacturing industry for them. And this is genuinely profound. And I think we're talking about, as a result of all that, a new industrial revolution, because every single industry is affected, and a new industry. Just as electricity became a new industry. At first, when it was described as a technology and demonstrated as a technology. It was understood as a technology, but then we understood that it's also a large industry. Then there's the information industry, which we now know as the internet. And both of them, because it affected so many industries, became part of infrastructure. We now have a new industry, an AI industry, and it's now part of the new infrastructure called intelligence infrastructure. Every country, every society, every company will depend on it. And you can see its scale. This is one that's being talked about a lot. This is Stargate. This doesn't look like a data center. It looks like a factory. This is 1 gigawatts. It will hold about 500,000 GPU dies and produce an enormous amount of intelligence that could be used by everybody. Our first contact was in 2012, just prior to that, working with developers on a new type of algorithm called deep learning. It enabled the AlexNet big bang of AI, 2012. In the last 15 years or so, AI has progressed incredibly fast. The first wave of AI was perception, for computers to recognize information, understand it. The second wave, which most of us were talking about the last 5 years or so, was generative AI. It's multimodal, meaning that an AI was able to learn both images and language. Therefore, you could prompt it with language and it could generate images. The ability for AI to be multimodal, as well as able to translate and generate content, enabled generative AI revolution. Generative AI, the ability to generate content, is fundamentally vital for us to be productive. Well, we are starting a new wave of AI. And this last couple of years, we've seen enormous progress in AI's ability. Fundamentally, intelligence is about understanding, perception, reasoning, planning a task, how to solve a problem, and then executing the task. Perception, reasoning, planning, the fundamental cycles of intelligence. It allows us to apply some previously learned rules to solve problems we've never seen before. That's why intelligent people are considered intelligent. To be able to take a complicated problem, break it down step by step, reason about how to solve the problem, maybe do research, maybe go learn some new information, get some help, use tools, and solve problems step by step. Well, the words that I just described are fundamentally possible today with what is called Agentic AI, and I'll show you more in just a second. In the physical implementation of that, the embodiment of that Agentic AI, and the motion, now the generative capability is generating motion. Instead of generating videos and generating images or generating text, this AI generates locomotion, the ability to walk or reach out and grab something, use tools. The ability for AI to be embodied in a physical form is basically robotics. These capabilities, the fundamental technology to enable agents, which are basically information robots, and embodied AI, physical robots, these two fundamental capabilities are now upon us. Really, really exciting times for AI. Hugging Face and NVIDIA has connected Lepton together. And so whenever you're training a model on Hugging Face, if you would like to deploy it into Lepton and directly into Spark, no problem. It's just one click. So whether you're training or inferencing, we're now connected to Hugging Face, and Lepton will help you decide where you want to deploy it. Let's take a look at it.
Developers need easy and reliable access to compute that keeps up with their work, wherever they are, whatever they're building. DGX Cloud Lepton provides on-demand access to a global network of GPUs across clouds, regions, and partners like Yoda and Nebius. Multi-cloud GPU clusters are managed through a single, unified interface. Provisioning is fast. Developers can scale up the number of nodes quickly without complex setups and start training right away with pre-integrated tools and training-ready infrastructure. Progress is monitored in real time. GPU performance, convergence, and throughput are at your fingertips. You can test your fine-tuned models right within the console. DGX Cloud Lepton can deploy NIM endpoints or your models in multiple clouds or regions for fast distributed inference. Just like ride-sharing apps connect riders to drivers, DGX Cloud Lepton connects developers to GPU compute, powering a virtual global AI factory.